would also recommend that you do question 5 on your own. So how much money will John have in his savings account after 5 years if he deposits £2,500 every 3 months starting immediately? Interest is calculated 12% per annum, compounded quarterly. See if you can manage to do this on your own. So could you pause the video now? Pause the video, and then mark it. Okay, welcome back. So we're here with John, and he's got this savings account. And so how much money will John have in his savings account after 5 years if he deposits £2,500? So we know X is equal to £2,500 into it's every 3 months, right? So that's per quarter, right? And interest is calculated at 12%. Interest is calculated at 12%, so 0.12 divided by 4, compounded quarterly. There's 4 quarters in a year, right? Good. How many payments are there? So 5 years. So 5 years times a quarter, right? 4 quarters in a year, so not times a quarter. You know what I'm saying? 5 times by 4 per quarter, and then plus that immediate one. This John is lekker harigad. Now he starts paying immediately, so that's including an extra payment. So that then is equal to 21 payments. And then you just nick it in there. So f is equal to x, 1 plus I to the power of n minus 1 over I, and what we've got is f is equal to, so £2,500, 1 plus by 0.12 divided by 4 to the power of 21 minus 1 over 0.12 divided by 4. You type that all in your calculator, and you're going to get 691 rand and 21 cents. Good. Hopefully you got that. If you got it, give me a high five. Yeah. Okay, let's look at question 6.1. So John saves 300 rand from his monthly salary in an account earning 8.5% per annum compounded interest compounded monthly. At the end of 10 years of working, he stops making these payments but leaves the money into the account to continue earning interest. So represent this on the timeline. So T0 is now. So for 10 years, he's going to keep on making regular payments, right, into that. So this part is going to be the future value annuity, okay? So then there's this amount of money after that's going to be accumulated, calculated after that last payment, and that amount of money will grow with compound interest, of course. So that will just grow. So that's just compound interest there. Okay, do you understand? So the future value annuity is only for the first 10 years, and after that, it's just going to be a compound growth. Okay, like we did in section A. Okay, let's look at this. So the first part is quite straightforward. X is equal to 300, right? That's his regular monthly payment. The interest rate is 8.5%, so 0.085, and it's monthly, so over 12. And then for how long will that be? So it's for 10 years monthly payments, and he doesn't do anything fancy like starts paying immediately or something. So it's default, so that's 120 payments he's going to make. Right, and we need to work out first of all the amount, this part here, the future value, how much money we'll get from that annuity that's now going to grow compoundedly. So let's look at this. So f then is equal to x, so that's 300, and then it is 1 plus by I, which is 0.085 over 12 to the power of n, 120 minus 1 over, and then I is equal to 0.085 over 12. So the future value for that first 10 years, he's going to get something like 56,000 rand, 441 rand and 52 cents. But remember, there's a lot of those decimals. Okay, so those decimals are important. So you keep that on your calculator. Just type that in and just check if you can get that. Okay, so now we need this amount of money now. This 56,000 rand is going to grow compoundedly for another 10 years, né? So because we want the account after 20 years. So that's going to grow for another 10 years. So that's just a simple compound interest growth, right? So present value 1 plus I to the power of n. So what will that be? The future value, the present value now is this 56,000 Rand, 441 Rand and 52 cents. It's best to use the answer button in your calculator, and and then, or to save it, to store it as a function, save it as A, and then 1 plus by I, that is 0.085 over 12 to the power of, and how many years? So that will be for 10 years monthly, so 10 times by 12, and so for 10 years, yeah. So so that's it, because the interest grows monthly. So then that is going to equal to 131,658 Rand and 16 cents. Okay, so he only got 56,000 Rand for the first couple of years, right? For the first 10 years, from his annuity, and then that money grows for 10 years, right? And then it grows to 131,658 Rand. Okay. The second part of question 6.2, talks about John's sister. So it's not John, his sister starts working at the same time as John, but does not have a savings fund for the first 10 years. Calculate how much John's sister needs to save each month if she has to have 130,000 Rand available at the end of the next 10 years using same interest rate of 8.5% compounded monthly. Okay, so we now know that she wants a future value of, the total future value should be 130,000 Rand. Okay, we don't know the monthly payments, that's all that it's about. We know that I is 8.5%, so 0.085 over 12, right? Because it's monthly. And we've got the number of payments. So that is going to be for that 10 years, right? She's going to for 10 times by 12, right? So she didn't say for the first 10 months. Okay, so let's look at the difference now. So it's going to be then the future value is equal to x, 1 plus I to the power of n minus 1 over I. So the future value, that is 130,000, is equal to x. X we need to work out. So it's 1 plus 0.085 over 12, that's I. N is equal to 120, that's 10 times by 12, minus 1 over 0.085 over 12. So what I would again think, what I think works best, encourage you to do is to save all of that as A or something. Save it in your calculator, and then then what you've got is you've got 130,000 is equal to x times by A, and then you divide A on both sides, right? And then you have the value of x. Right. And if you do that, just check if you can do that. That answer, therefore you're going to get x is equal to 690 Rand and 98 cents, which is quite significant. You would recall that John saved 300 Rand a month, right? And then he lands up after, for 10 years, and then he just leaves the money, and for 10 years he gets interest. So he only saved 300 Rand a month, actually. Cost him 300 Rand a month for 10 years. So this one, for John's sister, didn't start immediately, so it will cost her 690 Rand, almost 691 Rand for 10 years to get to the same value of 130,000 Rand. Question 7. So I think you can try this question on your own. There's two parts to this. 7a is calculate how much you could expect to be in his account after 30 years, and it's quite straightforward, well, except for one small thing. And then calculate how much he could expect to be, and then the second question, B, is to do with JOMA, and it's a comparison. Let's so try it on your own quickly. Let's look at question 7. I urge you to do question 7 on your own, and then just mark your answers. So you can pause the video, try it on your own. Okay, so question 7. John invests 500 Rand each month, so X is equal to that regular payments of 500 Rand. And then the interest rate is 8.5% compounded monthly, so 0.085 over 12. N is equal to how many payments there are, so how many payments is that? It's of 30 years, so 30 times by 12. And then just don't get confused here. So it's the first payment is made one time period, 1 month after is made after 1 month, and then the final payment interest earns no interest. So it's not unusual. It's by default. Remember it's one time period after starting it, and the last one doesn't earn any interest. And then what we need to work out what f is equal to. Right, so f is then equal to 500 Rand is x, and then 1 plus by 0.085 over 12 to the power 360 minus 1 over 0.085 over 12. Then the future value therefore is equal to 800, if you round off to 2 decimal places, 825,352 Rand and 86 cents. In question 7b, Jonah also started work at the same time as John and invested in the same scheme, so it's the same interest rate, but decided to deposit 600 Rand a month and not 500 Rand a month. Then, after a certain number of years, Jonah's investment accumulated to X, where X is the answer obtained in 7a. Okay, so that's 825,352 Rand. Calculate the value, or to calculate how long his investment accumulated to the nearest whole number. Okay, so what do we have here? So we know what the future value is. The future value, it must be the same as in 7a, right? So that is that 825,352 Rand and 86 cents. We know what X is. He's going to pay 600 Rand a month, right, into this account or into the annuity. And we know I is exactly the same, so that's 0.085 over 12. We want to now work out what N is equal to. Okay, so how do we do that? So you write down your formula, right? F is equal to X, 1 plus I to the power of N minus 1, over I. Alright, and we've got 825,352, 86 cents is equal to 600. 1 plus 0.085 over 12 to the power of, so how many, well, of course, that's what we want to work out, N, alright, and then minus 1 over 0.085 over 12. This is where calculator skills are very important again. So the first thing what you would do is you would multiply. So you want to land up with this, right? So you would multiply this on both sides to get this away on the denominator. So, right, so that it will look something like that. The next part is you're going to divide 600 on both sides. So if you divide 600 on both sides, then that's away. Alright, good. What's the next part you're going to do? Yeah, you're going to add 1 on both sides. So it's that plus 1, alright? And then you just keep on going through the motion. Right. So you're going to be left with, so that 1 plus 0.085 over 12 is the 1.007 and all the decimals. And then all the rest is then equal to 10.7437. And what do I do again if I want to solve if the variable I want is in the exponent? Yes, log. That's when we use logs. Remember, logs again is when you've got the base, the exponent is equal to the number, ben, so therefore log base number is equal to exponent. So if you want to write this in log form, what's it going to be? So it's log, the base is that 1.007, so you need to include all those decimals. Save that, for example, as A, so it will look like this, log A, and then you've got this part here, that's the number, and you save that, for example, as B, So that's that 10.7437 and that is equal to n. And if you work that out, if you just press that on your calculator, then you're going to get 336.3844 blah 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 blah. Okay, so what does that mean? So in what is that? That's in months. So 336.3844 months. How many? If they ask you that to n to the nearest whole number, right? The number of they ask you for the number of years? No, they ask you for months, so that's fine. So you can just round this off then to 336 months, right? And that is the same as then 28 years. All right. Okay, so question 8. I want you to try on your own as well. So first try it here by yourself. This is one of those questions where there's a annuity payment, and then it stops where it generates interest. So try that question on your own by yourself. All right, let's look at question 8. So we've got a future value there that we need to find. So John pays monthly amount of 1,500 rand into his annuity, and the interest rate is 9%, so 0.09 over 12. Compounded monthly for 30 years, so n is equal to 30 monthly, so it's 12 times by 30, well, if it's default. At the end of the 30 years, he stops his payment, but leaves the money into his account for a further 2 years. All right, so the first part, so for the first 30 years, there's this annuity that is building. It's making regular payments into it, and they're earning interest. And then for 2 years, as you can see, that's totally to scale. For 2 years, the money grows just compoundedly just for those 2 years monthly. Okay, so let's hit it. Let's do the first part, the future value annuity. So F is equal to, so it's 1,500 rand. That's the regular payment. 1 plus 9%, so 0.09 over 12 to the power of 12 times by 30. And then minus 1 over I, 0.09 over 12. And that is equal to, okay, so it's that amount, okay, but you can do this all at once. I think it's sometimes easier to do that all at once. So that's the annuity part that we just worked out. Now, after that, that money is going to grow compoundedly, right, for 2 years. So it's going to grow at that 9%, sorry. 0.09, 9% compounded monthly for how long? For 2 years, so 12 times by 2, right? And then you just type that all in your calculator, and then you get 3,285,489 rand and 41 cents. Okay. Okay, question 9 is quite a challenging question. Because what you've been given is an effective interest rate. So the effective interest rate is effectively how much interest you got per year, right? As from the beginning of the year to the end of the year, right? So how much interest, the actual interest rate. So if you want to work out the percentage your money grew, that is your effective interest rate. Remember the nominal interest rate, so that's 8.5% monthly. Is broken down into those little small parts. Remember, you get interest on interest. So if you've got 20% interest per year, effective interest rate, that doesn't mean you can just work out the monthly interest rate, just divide that by 12, right? Because, of the characteristic of interest, the compound interest. Okay, so there's this formula we use to convert between effective interest rate and nominal interest rate. So let me just state again. Nominal interest rate is like per month, 12% compounded per annum monthly, 8.5% compounded annually per annum monthly, right? Or quarterly, so it's broken up in those small parts, right? Effective interest rate is the actual interest rate for a year. Okay, so this person's money actually grew by 10% per year. Okay, so it's just a simple substitution part. So it's unlikely they'll ask you this in the exam, but I think it's good for you to know this. So the effective rate is 10% per annum effect. So 10%, so that is 0.1. I is, remember, the rate divided by 100. So it's 10 divided by 100 is equal to, so you just substitute that into the effective, and you're going to work out now the nominal. And this formula is actually very easy. It's kind of lets you think of simple interest, compound interest, and that's not bad if you thought about that. So 1 plus I nominal is equal to, so that's the one we want. We want to work out what the nominal interest rate is. And the nominal what? Is it monthly, quarterly, daily, weekly? What type of nominal interest rate are we working out? Well, we're going to we need month, starting 1 month from now. So we need monthly, a nominal monthly. So divide by 12 to the power of 12. Okay, and that's the only thing you need to do. I mean, then you just get the nominal interest rate there. So in other words, you're going to find the 12th root of 1 plus 0.1 is equal to 1 plus I nominal divided by 12. All right, and then you minus 1 from that, so it's the 12th root of 1.1 minus 1 is equal to I nominal divided by 12, all right, and then you times that by 12, so it's 12 times by all of that, 1.1 minus 1 is equal to I nominal, all right, and then for the rate, then you times that by 100, of course. So, and then if you work it out, just play around with that on your calculator, and then you're supposed to get 9.57%. So just check if you can do that. So why did we do this and not in other questions? Good question. So because they told you there's an effective. So if they just do the normal thing like all the other questions, or question 1 to 8 was just 8.5% per annum compounded monthly, 8.5% per annum compounded quarterly. This is now 10% per annum effectively. So then we just need to convert to the nominal interest rate. And the most difficult part here is to figure out if you're going to do monthly or quarterly or weekly or daily or secondly, I don't know, or annually. Well, you won't be annually because annually is effective. So and then that's kind of it. Okay, so the first part is to work out the interest rate is 9.57%. The nominal interest rate is 9.57%. So that means it is 9.57% compounded per annum monthly. Right, that's the nominal interest rate there. Okay, and then the rest of the question is quite straightforward. So the future value then is going to equal to, so the monthly payments he's making, so it's 1,000, so it's 1,000, 1 plus that interest rate 0.0957, right? What is it? Over 12, it's now nominal interest rate, so compounded per annum monthly to the power of how many? So it's 12 times by 10 minus 1 over 0.0957 divided by 12. And then if you type that in your calculator, you're going to get 199,875 rand and 60 cents. Right. So yeah, so the question is actually quite straightforward. It's that first part that is just a bit confusing. It's the effective interest rate that you just had to convert to nominal. And just let's revise that quickly again. So it's I effective, 1 plus I effective is equal to 1 plus I nominal divided by whatever it is. So the nominal you want. So 12 would be month. If it's 4 it will be for quarters. It's 4 quarters in a year. Biannually would be 2. There's 2. That happens twice a year, of course. So 2. So yeah, that's kind of the big story there. All right, grade 12s. So I've had some feedback that I don't encourage you enough after the lesson. So well done if you at this point you've made it, and you're probably tired of my voice. So well done. You've now done future value annuities, and that's not too bad, is it? I mean, question 9 is like one of the most difficult questions you're going to get. And if that's the worst case scenario, life is not too bad. Okay, so the next part is going to be sinking funds. It's a separate video, but it builds up on all these concepts. That's the easy part. Okay, well done guys. I'm so proud of you.